right, now we're on to problems 6 through 9 on review day number 9. The first one says that we have a particle in motion and the velocity is given to us here. We're told that the particle is at a position of x equal 1 when t equals 2, and we want to know what's going on at t equal 4. So the position at 4 seconds will be the position at 2 seconds, which was 1, plus the change in position from that time, which was 2, to the time we want to go to, which is 4, and of the rate of change, which is the velocity. So this equation right here. Okay, and this is calculator section, so we take our calculator, and I've gone ahead and plugged that in for y1. So I'm going to go ahead and just go 1 plus math 9, 2 to 4, alpha trace y1, dx, enter, and I get 1.353, which was option C. So not too bad there. Second one here, or number 7, gives us a graph, and it says the graph of function f is shown above of the following intervals on which is f continuous but not differentiable. So continuous means that we would keep our pen on the paper the whole time and never jump, never give any gaps or holes or breaks or anything. But not differentiable means that we'll probably have a sharp turn somewhere, right? So you see that from 0 to 1, we're fine. There's nothing wrong there at all. When I see 1 to 2, I have a discontinuity here, so it can't be 1 to 2. From 2 to 3, we're continuous, but we do have that sharp turn. So 2 to 3 is where it happens. 3 to 4, we have a discontinuity here, so that's why that one's not right. Okay, so that one's a fairly simple one that came kind of at the end of a test one year. Problem 8 gives us the first derivative, and they want to know on which of the following intervals is the graph concave up. So in order to be concave up, either our first derivative is increasing or our second derivative is positive. So we have an option. So I go to the calculator and go to y equal. I'm going to shut this one off now. I already have this stored into y3. Okay, so either I can graph this and see where this is increasing, or I can graph the derivative of this and see where the derivative is positive, whichever one seems easier. I'm just going to go ahead and graph this one right now. And again, this is the derivative, so I'm looking for where this derivative is increasing. And I can see that it initially increases from negative 1.5 to about negative 1.3-ish. And then again from like negative quarter, negative 0.25, all the way up to about 1. And so if I look at the options that are given to me, here's negative 1.5 to about what I thought. That's the other part. No, I'm not sure what that one's describing. This starts at negative 1.5, but it goes too far. So you can see that the increase doesn't go all the way to past negative 1 here. So of my choices here, A is the best one. If you wanted, if you felt really like you needed to know for sure, you could go and find those maxes and mins. But in a case like this, when your time is of the essence, if you know something's pretty close, you should be good to go. All right, and then we've got our final one here, number 9. They give us a rate that rainfall is coming down, and they want to know how much did the depth of the water in the rain gauge increase from 0 to 3. So this really is just a basic integration problem. R is the rate, so we're just going to go ahead. I have it already stored here for y5. All right, and so we can go math 9, the integral from 0 to 3 of alpha trace y5 dx, and I get 5.401, so we get D. All right, and then that's our answer.